Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Loka Gurukulam online classes. You heard about triangles, right? In your previous classes. Today we will have a special type of triangles called as similarity of triangles. This is a new word. You have heard about similar figures, similar twins. Now we will see about similar triangles. Before that, we should know the basics about triangles. What is a triangle? Is a plane figure having three sides bounded by three vertices and three angles. Is it not? What is sum of the three angles? 180 degrees. These are called three sides AB, AC and BC. These are called three angles A, B and C. There are different 6 types of triangles you already seen. And quadrilateral also. What is a quadrilateral? It is a plane figure. Come on. Anybody? It's a plane figure having 4 sides and 4 vertices. These sides, 2 of these sides meet at a point called vertices. Vertex. Plural of vertex is vertices. And one of the famous quadrilateral is you have square and then rectangle, you have rhombus, trapezium, then you have parallelogram, etc. Isn't it? All these are called quadrilaterals, and these quadrilaterals will have 4 sides and naturally 4 angles and 4 vertices and 2 diagonals. What are diagonals? The line joining the opposite vertices is called diagonal. So these things you already studied. Is it not? What are some of the 4 angles of a quadrilateral? Come on. 360 degrees or 4 right angles. Also you have seen in your previous class about congruency of triangles. Congruent triangles are those which have same shape and same size, and there are different criterias. Same shape and same size. Is it not? 2 triangles are said to be congruent under 4 conditions. One is if the 3 sides of one triangle are equal to the 3 sides of the other, then we say the 2 triangles are congruent. Or 2 side and 1 angle of one triangle are equal to 2 side and 1 corresponding angle of this second, then also we call it as congruent. Or you can say 2 angles and 1 side of one triangle are equal to the corresponding angles and side of another triangle, then we call it as congruent triangles. And in case of right angle triangle, the hypotenuse and one side of a triangle is equal to the hypotenuse and one another corresponding side of another triangle, then we say the 2 triangles are congruent. And how do you write it? Suppose you have triangle ABC, it is congruent to, like this you can write, triangle PQR. You can write like this, or you can write it as this also okay. So congruency means if you take that one triangle and keep it on the other, it will be identically equal. Also you have studied about the squares and square roots of numbers. How many of you know square numbers up to 25? Yes, many of you know, right? What is 10 square? 100. 20 square? 400. 25 square? 625. So like that up to 25 you have to learn it, okay? And square roots also. What is square root of 64? 8. Square root of 121? 11. And so on. We already studied in the previous class. And also we have heard about ratio and proportion. What is ratio? Ratio means comparison of identical items. Heights of two boys, weights of two boys. Same identity or quantity you must take. Is it not? And we use a symbol called is to. Suppose the weight of one boy is say 60 kgs, another boy is say 40 kgs. The ratio is 60:40. Here both kg, you must take kgs. Okay, if you are taking height means centimeters or meters. Proportion means what? If two ratios, say A is to B, is equal to another ratio C is to D, we use this symbol as is to. So when our two ratios are equal, we say they are said to be in proportion. And what is the condition? Product of means is equal to product of extremes. So A into D is equal to B into C. That is the condition of proportion. That also you have studied in class 8. And lastly, you know about the interior angle and exterior angle of a triangle. So suppose you have a triangle ABC. If you produce one of the sides, this is called exterior angle. If you have a triangle ABC, if it is produced to D, angle ACD is called exterior angle. ACB is called interior angle. ACD is exterior, ACB is interior. Sum of these two is 180 degrees. That also you have studied in the previous classes. Now we will come to the very interesting topic called similar triangles. So before you come to that, we will just recall what is congruent figures. Two geometrical figures which have the same shape and size. Size must be same, shape must be same. Then they are called congruent figures. So they are alike in every aspect. Similar objects means which have the same shape but not necessarily the same size. So size may be different. Shape must be same. Can you give some examples? So this is what is called similar. Congruent means same shape and size. Say two triangles ABC and DEF. Are congruent when the three sides of one triangle are equal to the three sides of the second. Or in other words, if one triangle is kept on the other, they will be identically equal. Whereas similar means the shape may be same, but size may be different. For example, all of you have seen photocopies, or you can say leaves of the tree. Here shape is same but size is different. See this is a small leaf, but this is a big leaf. All have got same shape but different sizes. That is why it is called similar objects. And one more beautiful example, see, is of photos of different sizes. What is this figure called? Taj Mahal. Where it is? Come on. Agra, near Delhi, right? So, what is this building about? That is a monument of love. Shah Jahan built this Taj Mahal in the name of his wife, and it is a world famous monument made up of marble. And here you see, this is also Taj Mahal photo, this is also Taj Mahal photo, and here the shape is same but sizes are different. See this. For example, you would have seen a stamp size photo. In photo you have stamp size, very very small. You have seen? And passport size, little bigger. Postcard size, little bigger. And then you have A4 size, still bigger. Lastly, life size, biggest. In all this, the photo of the person is same. Here also, see, this is smallest. Taj Mahal is same and all the three. And the shape also is same, this is rectangle. But sizes are different. So this is the smallest size. This is little bigger. This is biggest. Alright? Are you understanding? These are called similar figures. Similarly, you can have similar squares or rectangles, or you can have rhombuses, like that. Even coins also, 1 rupee coin and 2 rupee coin, they have got a same shape but sizes are different, right? So like that you go on listing out like this. Okay, now one important point you must note: two congruent figures are similar, but two similar figures need not be congruent because the sizes will vary. So need not be congruent. So note the difference between congruent and similar. Followed? For example, similarity of plane figures. Two line segments of the same length are congruent as well as similar, but of different lengths are similar but not congruent. Suppose you take this line is 4 centimeters. If you take this, say about 6 centimeters, both are line segments, but they are not congruent, they are similar. Okay, give one more example. There are two circles here, shape is same but radius is different. Suppose the radius of this is 1 centimeter, this may be 3 centimeters. They are not congruent, they are similar. So triangle, for example, equilateral triangle, both are equilateral triangle. They are similar but not congruent. I think you understood. Now let us see what is the condition of this similarity. Squares also, both are squares. Means what? All sides are equal. Here also all sides are equal. That means shape is same but sizes are different. Okay. So let us see the condition. Two polygons are said to be similar if the corresponding angles are equal. So that is number one. Second, the lengths of the corresponding sides are proportional. Need not be equal. They are proportional. So proportion must be same. Means the ratios must be equal. For example, here is a beautiful photo of pentagon. Pentagon means how many sides? 5 sides. So here, see, angle C is equal to angle C dash corresponding. B is equal to B dash. A is equal to A dash. D is equal to D dash. E is equal to E dash. So corresponding angles are equal and sides are proportional. Means what? Here if suppose you say this is 2 centimeters, this is 4. So all these are 4 centimeters. Let us suppose. So then all these are 2. So angles are equal. Sides are proportional. Means ratio must be equal. That is means suppose you have AB here. AB by A dash B dash is equal to, come on. So angle A is equal to A dash, B is equal to B dash, C is equal to C dash, D is equal to D dash, E is equal to E dash. Sides are AB by A dash B dash. AB by A dash B dash. That is corresponding sides are proportional. Means ratio must be equal. So BC by BC B dash C dash. So BC by B dash C dash. So AB by A dash B dash. And then BC by B dash C dash corresponding sides. CD by C dash D dash. DE by D dash E dash. AE by A dash E dash are proportional. Then we say pentagon ABCDE is equal to pentagon, is similar to pentagon A dash B dash C dash D dash E dash. Okay, we use the word similar. And what is symbol you write? Symbol is like this, sleeping S. Okay, so that is the symbol I use for that similarity. Okay, for example, if you say triangle ABC is similar to triangle DEF, this is symbol you use. Or congruency, this is a symbol, congruency. Triangle ABC is congruent to triangle DEF. Note the symbols correctly. Or you can use like this also. That also is allowed. Okay. So this is about similarity of figures or polygons. Now let us concentrate on similarity. So any one of the conditions is not satisfied, then the two polygons are not similar. For example, here are two polygons. What is the name of this? This is square. What is the name of this? Come on. Anybody? Yes. It is rectangle. Here you see angles are equal. How much it is? This is 90. All are 90. Angles are equal. What about sides? Sides are not proportional means AB by PQ is not equal to AD by PS. So ratio of the sides is not equal. Therefore, even though they look alike, they are not similar. Similarly, you can think of one more. Say if you have a square and rhombus. I am drawing a rough figure. Suppose you call this square as say ABCD and rhombus has XYZ, or you can say PQRS. Here we can think that sides are same. If you say it is 4, all sides in a square are same. Here also all sides are same. What about angles? Angles need not be equal. Here even though angles are equal, all are 90 degrees, it is not so here. Opposite angles are equal, that's all. But need not be 90. Therefore, they are not similar. Square and rectangle are not similar. Here angles are equal but sides are not proportional. Here sides are equal but angles are not equal. Therefore, any one of the conditions is not satisfied, then we say two polygons are not similar. Okay. So they are equiangular but they are not similar, right? Now about similar triangles, that is the topic of today. Two triangles are said to be similar if their corresponding angles are equal, corresponding sides are proportional. Corresponding, that is very important. Corresponding means, suppose you have triangle ABC and triangle DEF. So ABC is said to be similar to DEF if corresponding angles means A equal to D, B is equal to E, C is equal to F. That is what is called corresponding angles. If they are equal, then the two triangles are said to be similar. Second is corresponding sides are proportional. Means what? Sides, come on, name them. AB, corresponding side here. DE, corresponding side here. AC, there it is. DF. Note down, note down, note down. BC, EF. That is what is called corresponding sides are proportional. Then triangle ABC is said to be similar to triangle ABC is similar to triangle DEF. When these angles, corresponding angles are equal and sides are proportional. Got it? Very nice. Now we will see some results. Results on similar triangles. It's also called basic proportionality theorem, also called as Thales theorem. Thales is a very famous mathematician, rather geometrician. Thales theorem, also called as basic proportionality theorem. If a line is drawn parallel to one side of a triangle, so this is the triangle ABC. if a line is drawn parallel, you can draw it, come on. What happens? Intersecting the other two sides. So it intersects at D and D. They divide this triangle sides proportionally, means this ratio of the sides will be equal. So in triangle ABC, if DE is drawn parallel to BC, then we have AD by DB is equal to AE by EC. Followed? Okay. So this is what is called Thales theorem or basic proportionality theorem. Similarly, you can apply it to other triangles also. Suppose you name it as PQR triangle, and you draw the parallel, say ST. There also PS by SQ is equal to PT by TR. When ST is drawn parallel to QR. That is called Thales theorem or basic proportionality theorem. Of course, you are not going to study the proof of this, luckily not there for you. And even converse also is true. What is converse? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Converse. If you want to get distinction, you have to work hard. That is the statement. Converse. If you work hard, you will get distinction. Alright? So that is called converse statement. Here it is in theorem. What theorem we studied there, the converse also is true. Means, if a line divides, suppose a line DE divides this in the ratio of, see here, DE divides the line AB and AC of the triangle ABC such that AD is AD by DB, the ratio of sides. AD by DB is equal to AE by EC, then DE is parallel to BC. That is the meaning. Alright? So that is called basic proportionality theorem. For example, DE is drawn parallel to BC. AD is 3 centimeters. DB is 5 centimeters. And AE is equal to 6 centimeters. Find AC, they are asking. First you have to find out EC. Is it not? And how to find out EC? So answer is in triangle ABC, DE is drawn parallel to BC. Therefore, by basic proportionality theorem, you have ratio of sides AD by DB is equal to AE by EC. We call it EC, let EC be X. We call it as X. First you find out X. So AD how much? 3. DB 5 is equal to AE 6 by X. Cross multiply. 3X is equal to 30. X is equal to 30 by 3, that is 10 centimeters. Now they are asking AC. Therefore, AC is equal to, note down, first, AE plus EC. AE how much? 6. EC just now we found out, 10. 6 plus 10 is 16 centimeters. This is 2 marks question. For that you have to know basic proportionality theorem, or you can write a Thales theorem. That is the result. That is the reason for that. So D is drawn parallel to BC, then divide the two sides proportionally. That is the meaning of this. Noted? Okay. So we pass on next sum. Find whether D is parallel to BC or not. Give reasons for your answer. Here sides are given. So by basic proportionality theorem, AD by DB is equal to AE by EC. If they are equal, then we say they are parallel. That is 3 by 4.5 is equal to 4.5 by 5.75. So 3 by 4.5, shall we make it multiply by 10 on both sides? 30 by 45. It will be 15 2s are, 15 3s are. And this you multiply by 100. It will be 450 by 575. When you multiply 100, no, moves two places. It will be 55 ones are, 25 ones are 25, 200. 55 8s are. There is 55, 25 2s are, 50 3s are, 18 by 23. So this is not equal to 18 by 23. And therefore, the two ratios are not equal. Therefore, we can say DE is not parallel to BC. So here they are not equal. You can write separately. First you find out AD by DB is 3.3 by 4.5. Like that you do it. And then you write a second ratio. So this is equal to 2 by 3. Then you write AE by EC. That is 4.5 by 5.75. That is equal to 18 by 23. So as the two ratios are not equal, we say DE is not parallel to BC. That's all. Give reasons, they are studying. By Thales theorem, this will be parallel only if it divides. You can write the sides are, because sides are not proportional. Ratio of sides are not equal. That is the meaning. That is the reason. Okay. That's all for today. We will see some home assignment. So what Baba says, Baba is telling 3 P's we have to practice: purity, perseverance and patience. Purity of thoughts, words and actions. Perseverance means to do a work given until it is completed. Patience for the result. Result may not come all of a sudden. It takes its own time. So these 3 P's we have to practice. Now home assignment. In the figure 1 and 2, PQ is parallel to BC. Find the value of X. You have to find out X here and X there also. Okay, by using basic proportionality theorem. Thank you.